We're actually going to do 411 and 421 together, because the reality is when you're factoring trinomials, which is what we're talking about today, it doesn't matter if you're factoring a trinomial with a leading coefficient or without it, which that'll make sense shortly. It really needs to be done the same way. So we're going to cover the notes for 411 so you can have the vocabulary, same with 42, and then I'm actually going to show you how to factor. So a quadratic trinomial is a polynomial. Polynomial means it has many terms, so it could be like x squared plus 7, something like that. A quadratic trinomial has exactly 3 terms. That's where the trinomial comes from. And its greatest exponent is 2. So that means it's going to be x squared plus blah, 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 blah. That's how a quadratic trinomial is going to look. So if you think back to what you learned in Algebra 1, you learned how to FOIL, or how do you do the box method. This is a method for multiplying 2 binomials. And using the concept of FOIL is just a way to summarize the distributive property. We're going to talk about this in a second, but I need you to have the vocabulary to so you can do well in the quiz. And the concept of FOIL helps you remember how to multiply each term in one binomial by each term in the other binomial. So the FOIL method says that you take everything in the first parentheses and you multiply it by everything in the second parentheses. So you would do A times C and A times D, and that's where you get AC and AD. And then you would do B times C, which is where you get BC, and B times D, which is where you get BD. And what the words FOIL stand for, they stand for first, outer, inner, and last. And that's how we get them, because we multiplied the first term in each parentheses, and that's where the AC came from. The outside term in each one, that's A and D. The inside ones, that's B and C, and the last one's B and D. Now, you probably learned how to multiply using the box method, so that's what we're going to talk about, just to review. So if I wanted to multiply x plus 2 times x minus 3, most likely you did this. X plus 2 on top, x minus 3 on the side. And then you multiplied to fill in the boxes. X times x is x squared. 2 times x is 2x. Negative 3 times x is negative 3x. And negative 3 times 2 is negative 6. So we have x squared plus 2x minus 3x minus 6. And I can combine my 2x and my minus 3x together. And I end up with x squared minus x plus 6. I'm sorry, minus 6. That's my fault. Minus 6. And that would be my answer. And you could do the same thing with number 2. You could use the box method to multiply that out. So I'm going to let you do that on your own. And you should end up with the answer of x squared plus 9x plus 20. Well, today what we're going to be doing is we're going to be going backwards. We're going to learn how to go from something that looks like this back into 2 factors. So we're going to be going from a trinomial into the product of 2 factors. Now, this next part has all these letters in it. Again, we're just talking about what these letters mean so that we can actually get to the idea of factoring. I'm going to show you how to do that in a minute. So this arrow here is pointing to B, and B is known as the coefficient of the x term. C is known as the constant of the trinomial. And P and Q are known as the constants of the factors. Again, this is just vocabulary stuff. So there are some rules that come along with factoring. Again, these are just things that you need to write down because they're going to ask you on the quiz. So what you need to know is that the product of P and Q, so if I were to multiply P times Q, it's always going to give me C. Okay? So P times Q will always give me C. So in this example, C is 10. If I multiply 2 times 5, I get 10. So that's where that comes from. The other thing you need to know is that the sum or difference of P and Q, so P plus Q or P minus Q, is always going to equal B, the coefficient of the X term. So in this case, 2 plus 5 is going to equal 7. That will always be true. There are some rules that go along with factoring here. And again, we're just going to talk about these just so that, and fill this in so that you have this for your notes. So it says the coefficient to the X term, which is this term, is positive. I'm going to go ahead and fill that in all the way down. The second one's negative, third one's positive, the last one's negative. And then the constant term, the sign is starting with the first one. It's positive, then negative, then negative, then positive. Okay, so we're just filling those in. And there are rules of how these signs work. And if C is positive, what you need to know is that your factors are going to be the same. They're either both positive or both negative, depending on your middle sign. If C is negative, like these two, then your factors, what's in your parentheses, are going to be different signs. We're going to move on to 421. And we're going to do the notes for this section. So this lesson is a little bit different because it's talking about factoring trinomials where there's a number in front of x squared, whereas the previous lesson didn't cover that. So again, we're just going to go through the vocabulary and talk about how we do these problems. So this lesson is about factoring quadratic trinomials where the leading coefficient, or which is known as A, is not 1. This is very, 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 very important. The first step to factoring out a trinomial is to look for a common factor in all the terms and then factor it out. And that can include a -1, but it's only a -1 when A is negative. And we're going to look at some examples that actually discuss that so you can understand what that means. So if you look at this example here, I have 4x squared plus 24x plus 20. I'm trying to get this into 2 parentheses. That's my goal. But before I can actually do that, which we'll do that part of it later, I need to first look to see if I can divide all of these numbers by something. So if I look at the numbers 4, 24, and 20, well, they are all divisible by 4, so there's a common factor of 4. So if I divide that out, that means I'm going to write it as 4. And then if I divide 4x squared by 4, I get x squared. If I divide 24x by 4, I get 6x. And if I divide 20 by 4, I get 5. So my problem is really 4 times x squared plus 6x plus 5. And you'll need to get it like this so that when you do factor, which we'll do momentarily, you actually can get the right answers. Otherwise, you'll mess up somewhere along the way. So there's some rules that kind of go along with and they're similar to what we did last time. So R and S here are you multiply R times S, you're always going to get A. So in this case, 3 times 2 is going to give us 6. And this form right here, this is just what we call standard form. Okay, you won't need to know that for any sort of test or anything like that. It may show up on your quiz though. All right, the product of P and Q, just like before, P times Q is going to give us C, our constant at the end. So looking at that previous example, I'm going to flip, and it was on the other screen 5 times 1, and 5 times 1 does give us 5. All right, so now we're actually going to learn how to factor. So we're going to start with the most difficult problems, the ones that have the number in front. And our goal is going to be to get it into two parentheses to look like that. Okay? So you're going to be using the calculator for this. So the first thing you're going to do is you're going to go to y equals. And in y1, you're going to take 3 times 2, and you're going to divide it by x. Now notice I'm color coding this intentionally. This 3 here comes from the first number. The 2 comes from the last number. I will always divide by x here. And it's just x, nothing else, no coefficient. Don't worry about the 7. The second thing I'm going to do is in y2, I'm going to take my middle number of 7 and I'm going to subtract x. And again, you will always minus x on this one. So I'm going to do the first times the last divided by x, the middle minus x. And then you're going to go to your table. When you get to your table, you'll see this. You'll see x, y1, and y2. What you are looking for, what you are trying to find here, is you're trying to find where y1 and y2 are the same number. You're trying to find where y1 and y2 are the same number. Now this should occur 2 different times on this particular problem. You should see it at 6, 1, and 1, and 1, 6, and 6. That's where you should see it on your particular table for this problem. Now, once you have these numbers, you're only going to actually use the first 2. We just need all 3 to help us figure it out. But once we get to this point, we're looking at this number or this set. And notice they're the same. If I look at the first and second, I see 1 and 6 in both of those columns. Okay? So I'm going to take those 2 numbers, 6. Sorry, let me write these back in purple. 6 and 1. And I'm going to divide them by 3x. Now the 3 came from this 3 that's up here. Same place. The x, that's just kind of something you have to put there. Okay, you look at each of these fractions and you ask yourself, can I reduce them? Well, let's start with this one on the right. I cannot reduce 1 over 3x, so I'm going to leave it alone. And if I can't reduce it, then that tells me one of my parentheses is 3x plus 1. Now, 6 over 3, I can reduce that because 6 will reduce into 2 over 1. So 6 over 3 is really 2 over 1. So my second parentheses is 1x plus 2. And that is my factorization. So my answer to this original problem is 1x plus 2 times 3x plus 1. So that means my factors of 3x squared plus 7x plus 2 are 1x plus 2 and 3x plus 1. So we're going to do the odds from the checkup together. So I'm going to start with this first problem, 2x squared plus 10x plus 8. As I told you, I didn't do this on the last problem because it didn't matter, but the first thing you want to do is you want to see, can you divide all these numbers by something? And in this case you can. You can divide everything by 2, which means your final answer is going to look like this. It's going to have a 2 in the front of it. So I went ahead and divided everything by 2. I'm going to get x squared plus 5x plus 4. So now I'm going to use the calculator to help me figure this out. So I'm going to go to y equals. And I'll always take the first number, which in this case is 1, times the last number, and I'm going to divide it by x. Sorry, I wrote the wrong thing there. That should be 1 times 5. I'm sorry, 1 times 4 divided by x. And then I'm always going to take the middle number, which in this case is 5, and I'm going to subtract x. And if one of those numbers was negative, the 5 or the 4, I would also take that sign with it. Then I'm going to my table. So I have x, y1, and y2 in my table. Remember, I'm looking for where y1 and y2 are the same. And it's going to show up twice in your table. You're going to see it at 1, 4, and 4, and you're going to see 4, 1, and 1. And again, you're only focusing on those first two numbers. Doesn't matter which set you pick. So I'm going to take 1 and 4, and I'm going to divide them by, go back up here, this very first number, so 1x. And I'm going to see if I can reduce. I can't reduce 1 over 1. I can't reduce 4 over 1. So that means my final answers are x plus 1 and x plus 4. So going back to what I had at the beginning, I had that 2 in front. One parentheses is x plus 1. The other parentheses is x plus 4. So another example, number 3. It says 4x squared minus 4x minus 8. First thing I'm going to do is I'm going to see if I can divide all these by something. As a matter of fact, I can. I can divide everything here by 4. When I divide it by 4, I'm really left with x squared minus x minus 2. So I'm going to go to y1, and I'm going to do the first number, which is 1, times the last number, which is negative 2. I'm going to divide it by x. Then I'm going to do in y2, the middle number, which is a negative 1, and I'm going to minus x from that. And then I'm going to go look at my table. And again, I'm looking for where y1 and y2 are the same. You're going to find it again in two places. It's going to be the same at 1, negative 2, negative 2. And then it'll also be the same at negative 2, positive 1, positive 1. You're focusing on one of those sets. It doesn't matter which one. I'm going to take those numbers. So we'll do 1 and negative 2. I'm going to divide them by the coefficient here, which is 1x. I can't reduce 1 over 1. I can't reduce negative 2 over 1. So that means my parentheses are 1x plus 1 and 1x minus 2. So my answer is 4, because that was from what I factored out earlier, and 1x plus 1 and 1x minus 2. All right, so number 5. I have 6x squared plus 11x plus 3. First thing I'm going to do is see if I can divide all these by something. Well, 11 is prime, which means I can't divide it by anything, so I cannot divide all three of these by something. So I'm going to go ahead and start off with y equals. And I'm going to start with y1. And in y1, I'm going to do the first times the last divided by x. And in y2, I'm going to do the middle minus x. And I'm going to go to my table. Okay, and we're looking again for where y1 and y2 are the same. What you're going to see in your table is 2, 9, and 9, or 9, 2, and 2. They're both going to show up. Doesn't matter which set you pick because they're the same. So I'm going to do 9 and 2, and I'm going to divide them by the coefficient, which was 6x. And I'm going to see if I can reduce. Well, 9 over 6. 9 and 6 are both divisible by 3. So if I divide 9 by 3, I get 3. 6 by 3, I get 2. So that leaves me with 2x plus 3 for one of my parentheses. 6 over 2, I can divide both of those by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. So that leaves me with 3x plus 1 for my other parentheses. So my answer is 2x plus 3 and 3x plus 1. Problem 7. 12x squared minus 17x minus 7. So I'm seeing if I can divide everything by something, and I can't. So I'm going to go ahead and start with y equals. So in y1, I do the first times the last divided by x. In y2, I do the middle minus x. And then I go look at my table. And what you're going to see in this table is two things, 4 and negative 21 and negative 21, or you're going to see negative 21, 4, and 4. So it doesn't matter, I'm focusing, which set I focus on, they're going to both work out. So let's see, I'm going to take negative 21 and divide it by 12x, and I'm going to take 4 and divide it by 12x, and I'm going to reduce. Well, 21 and 12, I can divide both of those by 3. 21 divided by 3 is 7. 12 divided by 3 is 4. So I end up with 4x minus 7. 12 over 4, I can divide both those by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. So I end up with 3x plus 1. So my factors are 4x minus 7 and 3x plus 1. All right, one more problem. We're going to do number 9. And number 9 is really nice. It says, given the factorization, you're supposed to find the trinomial. So this time, instead of factoring, we're actually going to go forward and multiply this out. When you have to do this, the easiest way to do these problems is the box method. When you have something like this in front, always save that for last, by the way. So in my box, I'm going to do 3x plus 2, and I'm going to do 4x minus 1 on the side, and then I start multiplying. 3x times 4x is 12x squared. 4x times 2 is 8x. 3x times negative 1 is negative 3x, and 2 times negative 1 is negative 2. So if I write this out, I have 12x squared, a positive 8x, a minus 3x, and a minus 2. I can combine 8x minus 3x, and 8x minus 3x is 5x, so I have 12x squared plus 5x minus 2. I'm not quite done because don't forget that we did have this 2 here in front, the negative 2, so we have to now multiply all of this by negative 2. Well, this is just the distributive property. Negative 2 times 12, that's going to be negative 24x squared. Negative 2 times 5, negative 10x. And negative 2 times negative 2 is positive 4. And that's going to be your answer.